everyone. This video is going to discuss codominance and incomplete dominance. So our previous Punnett squares that we showed, we talked about autosomal traits and then we also talked about sex-linked traits. And when we discussed those monohybrid crosses or those Punnett squares, they were all what we consider to be complete dominance. But what happens when you have incomplete dominance? So for instance, when we think about what happened with Gregor Mendel is we talked about how he started this sort of hybridization and he started crossbreeding plants and he got purple and white for the most part, but sometimes he would generate a pink. So that means that between the two alleles, there was kind of this middle ground. So I want to give you an example. Let's talk about hair texture for a minute. If you had straight hair is going to be what we call homozygous dominant. So both parents have to give the dominant allele for someone to have straight hair, like myself. But let's just say hypothetically, one parent gives a big or a dominant trait, and the other one gives a recessive. This person is heterozygous, but they actually end up with wavy hair. And then this one ended up with straight hair. And then we can also have where we have homozygous recessive. Now this person is going to have curly hair. So if you will, there's almost like this kind of mix between them. So let's give an example. Let's just say you have a dad that has straight hair. So dad has straight hair. So we already said that straight hair looks like this. It's that homozygous dominant. And mom has wavy hair. So she is heterozygous. And I'm going to fix this just because I like to be able to tell the difference. Big S, little s. Let's do a Punnett square and see what the chances are of having a kid with curly hair. All right, so I'm going to put mom at the top. I'm going to put dad on the side. All right, this one is big S, big S. That's a kid that's going to have straight hair. Big S, big S. That's another kid that's going to have straight hair. Big S, little s. That's a chance for wavy hair. Big S, little s. That's another chance for wavy hair. So when we go to look at this Punnett square, there's a 50-50 shot of having a kid that's homozygous dominant, aka they're going to have straight hair. And again, this is every single time mom and dad reproduce. There's a 50-50 shot. It's not 2 out of the 4 kids will have straight hair, 2 of the 4 kids will have wavy hair. It is every single time they go to reproduce. And then there's a 50-50 shot of having a kid with wavy hair, this heterozygous trait. So there's actually no chance of having a child that has curly hair because they don't have that homozygous recessive trait. Both mom and dad would have to give 2 little s's because one's giving a big S and one's giving a little s. There's still that incomplete dominance taking place, but they're going to have wavy hair instead. Okay, now let's talk about what happens when there's not a dominant and recessive trait. What we call this is codominance. And the best way to describe this is when we think about blood type. So when we talk about blood types, you can either be A blood, you can be B, you can be AB, or you can be O. Those are the 4 different types of blood you could potentially be. Same thing, mom's going to give an allele and dad's going to give an allele, but let's just say hypothetically mom was A and dad was B, and they came together and made a child that had AB. The A or the B is not dominant over the other one. In fact, they sort of share, kind of like a co-team, if you will, or a co-worker, or if you think about like co-managers. They're working together and neither one is dominant over the other. But what this looks like in terms of genotype is a person can look like this, where they are homozygous for A, Or they can be heterozygous, where they do have an A, but then they kind of don't have this allele, or we consider it to be like the O allele, if you will. So they can be homozygous, in which both parents gave an A, or we can have it set up that one parent gave an A and one parent gave this little I that we'll kind of discuss as O. All right, for B, they can be homozygous or they can be heterozygous. For AB, mom or dad has to give an A, and then the other parent has to give a B. They can't be anything else. One came from mom, one came from dad. Doesn't matter which one, but that child ended up being AB. And then for O, someone like me, both my parents had O blood type. The only allele they had was this. So that was the only thing I was able to get. And so because of that, I'm considered to be O blood. So let's kind of try this a little bit and see what we can end up getting. Let's just say hypothetically, my parents weren't both O. Let's just say my dad was A. Let me fix that a little bit. My dad was A blood, and my mom was O blood, and I still keep my blood type. Well, how can this happen? Let's go look at some Punnett squares. If my dad was homozygous for A, and my mom had this for her genotype, those two little I's, and I also have that little I, let me show you two scenarios. I'm going to put mom on the top. I'm going to put dad on the side. If this is the case, and let me actually make him homozygous here. If this was the case, every scenario would come out that I would have A blood. So that can't be what happened because then that wouldn't be my outcome. So my dad had to be heterozygous. And you get mom. Because again, there was a chance that I could have A blood. But because dad and mom gave that little I, there would be a 50-50 shot that I could have A blood or a 50-50 shot that I could have O blood. Let me show you what happens if maybe dad was A and mom was B. All right. So if dad was A blood, and let's just say he's heterozygous. So he looks like this. And mom was B blood. B blood. And we'll also say she's heterozygous. Then let's see what the scenarios could be for their potential kids. So I'm going to put mom on the top. I'm going to put dad on the side. And oops, let me fix that. So there's a shot of having a kid with AB blood. There's a chance for having a kid with A blood. There's a chance for having a kid with B blood. And there's also a chance to have a kid with O blood. In this scenario, you could have all the different blood types. And it has to do with the fact that both mom and dad were heterozygous. They both had that little I. And then also, again, they both had a different blood type. One had A and one had B. Now, let me give you now a new example. So, like I told you, I am O blood. So I look like this. But my daughter has B blood. Now, here's the scenario. She cannot be this because I couldn't give that to her. I could only give her that little I. So she looks like this. And we had her tested when she was born. She has B blood. I have no idea what my husband is. And I'm going to actually put dad. So let's cross this out. We'll say mom and we'll say dad. We have no idea what dad is, but we can make some assumptions of what he potentially could be. So let's look at some Punnett squares. If I look like this, and again, I don't know what my husband is, but I know that there had to be an outcome for IBI. Let's just say, for instance, I know my husband has to have a B somewhere in his blood. So he could potentially be homozygous dominant for B blood. And then my daughter came out looking like this. That would be her only outcome. It could also be that my husband has AB blood. So there was a shot that she had A blood, and there could also be a shot that she had B blood. It would have been a 50-50. But there's no way that my husband had A blood and just that. That wouldn't make any sense because she would be B, and I could only give that little I. Now, there's also a chance that he could look like this too. And then I give an I. And then she could have still came out B, but then there also could have been a chance that she was O. So my husband's either going to be homozygous for B, he's heterozygous for B, or he's AB. So any of those outcomes could have made my daughter have B blood, but he couldn't just be A and he couldn't just be O. So I actually mentioned this in class a few days ago, that I had a student that had O blood. And we were talking about blood types. And so again, for her to have O blood, mom had to give this and dad had to give this. She had to get one of those alleles from mom and dad. But the funny thing is, she said, huh, I think that's weird. I think my mom told me that she has AB blood. And so if mom had AB blood, she would look like this. So let's just say hypothetically, dad was O. So he looks like this. And again, mom did have that AB blood. The only outcomes you could potentially see are a heterozygous A or a heterozygous B. So she would either have had B blood or A blood. Now, the student could have been mistaken, and her mom did have A or B or O, but actually, what she ended up finding out was that she was adopted. So kind of an interesting way to end the class. But all right, I hope this helps. Hope you are having a wonderful day, and I'll talk to you again soon. Thanks.